Anybody else? All right, Paige. Okay, tell me what you found for your pencil.
6 grams.
6 grams. 6.0 grams, okay? What was the volume of your pencil?
5 milliliters.
5 milliliters, perfect. And then how do we find density? How did it say to find density?
Density equals mass divided by volume.
Perfect, okay? All right, so when you put this into the fraction, 6 divided by 5, right? Because mass goes over volume, right? But we have to figure out how to divide that. So which one goes into the little house when you're dividing? I know this is elementary, but today we've forgotten. Haley?
6.
6 goes under and 5 goes on the outside, right?
Mm-hmm.
All right, so if we work that out, it goes in once. Okay, 1 left over, we add a decimal. Okay, it can go in, what, another time? 2 times. Twice. Okay, so 1.2. All right, so the density of this pencil is about 1.2. Yours should be anywhere from 0.9. Did anybody get under 1 a little bit? To a little bit 1 point. It should be around 1. Yes? Since you're comparing mass to volume, right, we're going to label it just like that. It's going to be grams per milliliters. That's how you label it. All right? So if we can label it like this, can we also label it like this? Absolutely, because remember, volume is centimeters cubed, cubic centimeters, or milliliters. Okay? So good. That's the pencil. Let's do the orange. Another group. How about Taylor? What's your orange? What was your orange's mass?
81.2.
Okay, 81.2.
75 milliliters.
You forgot your grams. And
75 milliliters.
75 milliliters. Yours should be somewhere around there. Some of these oranges are a little bit bigger, but they should be somewhere around it. Yes?
We got 100.
Okay, that's okay. Yes?
We got 90.
Okay, a 90, 100, it's okay. All right, so again, mass divided by volume. So 81 divided by 75. Okay, work it out. It's probably going to be a little bit over 1. What'd you get? 1.9?
1.09.
1.09. So rounds to 1.1. Okay, so 1.1. All right, when we label it, grams per milliliters. We're going to come back to this in a second. All right, about the peeled orange, and another group. How about Monet? But what about your group? 76.4, so a little bit less, right? Because we lost the peel. That makes sense. A little less mass. What was your volume? 65 point what? Okay, 65 milliliters. Okay, and again, mass divided by volume. Okay, so I'm gonna get rid of this. 76.4 divided by 65. Okay? So y'all's are all bigger than everybody else's. Other classes had some smaller numbers below 1.
Water may have did something. Water may have did something.
Yeah, okay, so what do you think? What do you think the peeled oranges have done all day?
They soaked up.
Yeah, they've absorbed the water. Okay, so that's probably why it's changing. Okay, so again, we're going to go in once. And what did you get when you divided? Is that 9? Is that right? Yeah?
Yes.
Yes. So about 1.1? Who was that? Was that you, Monet? 1.1? Okay, grams per milliliters. Perfect. Okay, so we're going to come back to this in a second. All right? So just hang on to this, and we're going to relate it to this, come back to it in just a second. Why don't you pause that? We said that, how do we find density? Kelsey, how do we find density? Perfect. So I'm going to teach you this triangle, which it's just kind of a trick to manipulate this, manipulate and solve for a different variable. Algebra, yes. So if you wanted to solve for something else, this is kind of a little easier way to remember it. So I'd like you to draw your triangle, and in the triangle, I'd like you to put a T. Okay, so you're going to divide your triangle into 3 parts. And then we're going to do just what we just said. We're going to write this formula in the triangle. So we're going to start with density. Density equals mass over volume. Therefore, it's the same way that you wrote it right here. It's just in the triangle. Okay? And then how do you solve for density? What do you do to mass and volume? You divide. So I'm going to add my little division symbol here. So that helps me to remember that if I'm looking for density, I divide mass by volume. I'm also going to put a little division sign here. Because when we solve for volume, we're going to divide the mass by the density. And then guess what? Just like if you were trying to get m by itself over here, what would you do? You would divide this side by V, and then what would you do to the other side? Divide it by V, right? And that would get rid of the V's, yes? It's algebra. Shake your head like you know what I'm talking about, even if you don't. Okay, thanks. All right, so we're gonna multiply the D times the V, so just put that in there, okay? So you're gonna use this on Thursday. I've sent you a lesson, and we're gonna kind of use this, and it's just kind of, if you're solving for density, mass divided by volume. If you're solving for volume, it's mass divided by density. If you're solving for mass, it's
Density
times volume. Okay, we're just gonna learn to use that, okay? So we'll come back to that. So in your rectangle here, I'd like you to draw 5 layers, because we're gonna do a little density tower here with some liquids, and we're gonna see what happens, okay? All right, my last cup of the day, here we go. I'm gonna save this one too. The other classes where you save it, because I've rinsed it out. All right, so we're gonna start with Karo. We're gonna layer some different liquids. What do you know about Karo syrup?
Thick.
Very thick. It's full of what? Sugar. It's very sweet. It's very thick. It's very sweet. Lots of sugar in it. So I'm going to pour it in first. Kind of pour in a lot so you can see. Okay, so there's our Karo. Okay, on top of the Karo, I'm going to put some Dawn soap. Okay, I'm just going to pour it right on top and slice in blue so you can hopefully see it. Okay, lots of bubbles. All right. Okay, then on top of the blue, you can see that layer of blue. I think we need to add a little more blue. What do y'all think?
Yes.
Okay, let's get a little more blue. Yes, more. All right, so add a little bit more blue. And I'm going to leave it so y'all can see it tomorrow. All right, then on top of the blue, we're going to add water. Now, what happens when you add water to soap? Bubbles. Okay, so I'm going to try really hard to pour it down the edge so we don't get a lot of bubbles, but kind of been successful today and then kind of not. Okay, so at first they kind of mix, and then the longer you let them sit, they kind of will separate back out. Try to get it all in there.
That's cool. That's so cool.
Okay. All right, so there's the water. Oh, burnt. I'm like, okay, then on top of that, we're gonna put some oil. Okay. And again, when this hits the water, the oil is going to kind of try to mix with the, in fact, let me try to pour it in the middle. It's going to try to mix with the water and the soap just from it hitting it. But the longer we let it sit, what do you know about oil and water? They don't mix, okay? Oil always rises to the top. So eventually they will separate out while we do the other thing. We'll let it watch. And then on the very top, I'm going to put some rubbing alcohol. Okay? And then we'll let it sit there, and we'll come back to it in a second after we talk about some things in here. Okay? So we'll let it sit there, and it'll kind of all separate back out, and we'll talk about it. Okay? So while we're waiting for that to separate back out, let's talk about this water. Actually, let's talk about this word buoyancy. Go ahead and write that word buoyancy. What does it mean to be buoyant or buoyancy? What is it, Sarah Lynn? Ability to float. Okay? So ability to float. Okay? Why would I be talking about the ability to float on the same day I'm talking about density? If you have any idea? Sarah Lynn again. Anybody else? What do you think?
Some things will float because they are less dense.
Okay, so you think that density has to do with buoyancy. They're related. Okay. Does anybody agree with her? Okay. All right, so we're going to talk about things that are ability to float. Okay, we got water. This is our medium, our water. Okay, what do you know about this rock? It won't float? Okay, tell me about this rock. This is one of the rocks from your math labs. What do you think about this rock? It's smooth, but what do you think about its ability to sink or float? Well, somebody tell her, what's this rock? How would you describe this rock?
It's a mineral.
Huh? It's a mineral? How would you describe it?
It's solid.
Solid. So what do you mean by that?
There's nothing really inside it except for just the rock.
Nothing inside of it except the rock. Okay, somebody else want to explain how would you describe it? Yeah?
Particles are tightly together.
Whoa! Swinny, very nice. Okay, so what is that word when molecules are packed really close together?
Solid.
Yes. What else is it? Yeah.
Dense.
Dense. Very good, Rachel. So this would be the rock. Very close together. Very dense. Okay. Over here we're gonna have the less dense, right? The molecules are more spread apart. So the rock's obviously gonna what? Sink. I got another rock. A bigger rock. Does this rock take up more volume than this rock?
No.
What's volume? What's volume? Amount of space. Does this one take up more space?
There is a hole.
It takes up more space in this classroom, does it not? Yes, this is more
That
space.
does not look like a rock.
Okay, she doesn't think it's a rock.
It's not.
It is called a pumice stone. It is rock.
Really?
It is hard. It is rock. It has not been on my scratching my feet, so no, you touched it. No, it's a new. It is what you use to clean your heels. I usually bring a yucky, dirty one, but I bought a new one for you, so you wouldn't have to touch it. So, is it gonna sink? Did you feel it? How would you describe a pumice stone? Does anybody else know? How would you? A good word. Somebody last class used this word, and I loved it.
It's got like little holes.
It's got holes in it, so that means there's what in it? Air. But there's a word that means starts with a P. Have you ever heard the word porous?
No.
Okay, porous would mean it has, like SpongeBob, exactly. And he absorbs water. He has lots of holes, right? He's a sponge. He's porous. Okay, so this has lots of air in it. So do you think it's going to sink or float?
Float.
Even though it's bigger than the other rock? Okay, so it floats because it has air. So even though the volume's bigger, is the mass as much? Less mass, less packed together. Okay, so what about the rubber bouncy ball? Sink or float?
Sink.
Watch it. Oh, it kind of bobbled, didn't it? It was like, oh, I don't want you. We're gonna think about ball, but you can see it's right under the water, so it's a little bit less. Definitely, the ping pong ball is what? Top of the water. What about a piece of wood? Float. Toothpick or a piece of top. Okay, so now I want to ask you about these Cokes. While we're still, see, look, it's starting to come out. Okay, density is mass compared to volume, is it not? Okay, so if these Cokes have the same volume, which means the same space, right, in the classroom, and tell them how much milliliters is in each one, right here.
355.
355 milliliters in both?
Yes.
So you're saying they have the same amount of liquid?
Yes.
Yes? And they are the same space in this classroom?
Yes.
Okay, so they should do the same thing in the water.
No.
Okay, who thinks, turn to your neighbor and tell them what you think's going to happen. One is going to sink, one's going to float, same, both, different.
That's what I was gonna say.
All right, here we go. So I'm going to turn them upside down, and I'm going to push them down. Same volume, and density is mass compared to volume per object. So since the volume's the same, they should do the same thing. Okay, so why does one sink and one float, Kendall?
One has more sugar.
One has more sugar. So that means even though the volume's the same, there's more stuff, sugar, inside. Very good. The Coke has more sugar. In fact, if I take the Coke out and we let Bailey tell us how much sugar's in it, look on the back. Sugars, how much sugars?
39.
39 what? Grams. 39 grams of sugar in the Coke. This is 39 grams of sugar right here. I measured it out on the triple beam balance. Yes, all your hips, ladies. No sugar. Okay, this Diet Coke does have fake sugar, but it doesn't have as much, right? So there is more stuff, right? More mass per volume, because the volumes are the same, but there's more mass. Does that make sense? So it's heavier. Or it has more density.
Can I call dibs on that Coke?
No, I've had those for 3 years. Nope, they sit on my shelf. Sorry. Okay, so let's go back to, okay, and I want you to think, I'm going to put the pumpkin in the water at the end of class. So I want you to think about whether the volume's really big, but I want you to think about the mass of the pumpkin. So like what's inside, okay? Whether you think it's going to sink or float. All right, go ahead and push pause.